Hello, DevFest. How are you? Okay. Do you enjoy your meal? Okay. Do you have some energy left? Because the afternoon will be a little bit hard. You know, it's the first day of the DevFest. So, have you some energy? Ah, starting to digest. Try again. Have you some energy left? Ah, it's better, it's better. So, during these 2 days, we will enjoy and we'll enjoy our deepest fear as a web developer, you know. So, we are always struggling, always afraid of our past. But what about our future? So, today, in order to help you about that, we will welcome Melissa. So, she came from deeply on the street of London. She works at Google. Please welcome Melissa.
One more time. Hello, everyone. Bonjour. Merci for so many applauses. Thank Matthew for introducing me. So my name is Milica. I specifically work as a technical writer in Chrome Developer Relations team. I work on online identity and authentication, but along with that, I also work on browser extensions, and previously I worked on privacy and web performance. So if you want to talk about any of these topics, I'll be around all day today, and I'm happy to chat. You can also find my articles on web.dev and on developer.chrome.com if you want to say hello or chat. After the presentation about anything, I'm Bibi Digital on Twitter, and you can also find my email on my website. Now, what are we here for today? I'd like to talk to you about our future without passwords. But before we start, here's a little preview of what I will cover. We can't really talk about getting rid of passwords before first talking about passwords. With that out of the way, the topic of my talk today will actually be passkeys. I'll tell you how they work, I will show you how they work, and I'll go over the benefits they offer. We will learn more about security features of passkeys and the state of support today. We will take a look at the anatomy of a passkey system and how you can get started implementing passkeys in your authentication flows today. So, without further ado, let's get started. Passwords have been around for a long time, but they're a pain for users, and they're a liability for you as a developer. Strong passwords are really difficult to remember, so many people don't bother creating strong passwords, or they reuse the same password for everything. Now, I looked into some research, and what I found is that bad habits die hard. So 2/3 of people reuse their passwords across accounts, and 1/3 of them even shares passwords with other people. Now, let's do a little show of hands. How many of you had to reset your password in the past year? Yeah, right? I know. Well, we are not the only ones. About 90% of people had to reset their password several times a year. And actually, while we are in like the horror, spooky mood, 6% of people said they do it daily. Right. Now, we're mostly developers here, and I know what you're thinking. Password managers exist, and password managers help here. And that is correct. I don't know, like, which password manager are you using? No, I'm joking. Password managers really do help. They can generate a strong password, synchronize it across apps and domains, and autofill it to all the right places. Now, we have password managers embedded in our browsers, like Google Password Manager, Some are standalone apps, like 1Password, Dashlane. Whichever you use, that's great. But the reality is, not everyone relies on password managers. There was a recent survey by Okta where people responded that over 2/3 of them feels overwhelmed by the difficulty of managing passwords. And managing passwords aside, the thing is, they're just not very secure. Over 81% of hacking-related breaches is caused by weak or stolen passwords. Now, as a developer, if you store user passwords, you are the one who's responsible for all the risks and consequences of hacking. And hacking is only part of the problem. Passwords are also susceptible to phishing. Now, a phishing attack is when someone tricks your user into revealing a sensitive information. Now, you know when you go to a site and it looks exactly like your banking site. The sign-in form is there, the logo is there, everything looks fine on first look. However, the URL looks kind of weird. So no matter how many capital letters and numbers your password has, it will not protect you from this risk of phishing. Now, this happens even to the most technically educated of us. It's just a matter of attention. So phishing scams have actually been on the rise, and they've increased nearly 12% since 2016. Now, you may be thinking, but we have two-factor authentication, right? And correct. So two-factor authentication improves security. However, one, it adds an extra step for users. And two, it can cost you money. So all those SMSs and emails are usually not free to send. But that's why we're here today. I want to tell you about the new, easier, and safer way to sign in on the web with passkeys. Now, passkeys are a simple and secure cross-device authentication technology which enables signing into online accounts without entering a password. What is a passkey? So a passkey is a unique cryptographic pair which is tied to a user account and a website or an application. Here's how that looks. So on sites and apps that implement passkeys today, the browser or operating system will show user a prompt to create a passkey. Now, what user needs to do is use their screen lock, which can mean touching the fingerprint sensor or using the face scan to continue. They don't need to type in anything. Then once the passkey is created, to log into their account, they will simply use the same method to unlock their device. The browser or the operating system is the thing that will ensure that each passkey can only be used for the same services it's registered on, which is what makes them phishing resistant. So unlike with passwords, users can be tricked into using their passkey on a sketchy app or website. Now, I think this is really important to highlight, is that passkeys are developed by FIDO Alliance, which is an open industry association which works on developing and standardizing technical specifications which reduce our reliance on passwords. Now, FIDO has been working on getting rid of passwords for over 10 years, and members are all major tech companies, which includes Google, Apple, Microsoft, and other big industry companies. So it's really important to remember that passkeys are an open standard. They are not proprietary technology of any one browser or platform. Now, what FIDO Alliance also does is conducts research. And recently, they published a report where they found that 58% of consumers in the United States have abandoned purchases because of difficulty of managing passwords. I'm saying this so you understand that improving the user experience can have a direct impact on your business. Now, sites that implement passkeys have seen a number of benefits, such as higher sign-in success rates, reduced sign-in time, increased conversion rates, and importantly, reduced costs of two-factor authentication. And there have been many sites and apps that have implemented passkeys in recent time. So just some of them are PayPal, Kayak, Amazon. And they've learned a lot in the process. So Amazon customers find it easier to sign in with passkeys compared to passwords or codes. Google Accounts users, 64% of them finds passkeys easier to use. And Kayak found that passkeys users can sign in successfully twice as fast than passwords on average. Now, the list of sites that use passkeys keeps growing every day, and you can check it out on passkeys.directory. Now, I have another question for you all. How many of you here has used passkeys? OK, this is really exciting to see. Like, every time I come on stage, more and more people. However, I don't see all the hands up. So let's try a different question. How many of you here has a Google account? Like, you use Gmail or any Google service? OK, a higher number. Well, for the difference between the two polls, everyone who has a Google account can try passkeys today. Because since May last year, passkeys are supported across all Google accounts on all major platforms. So if you visit this link now on your phone, I promise you it will only take a few seconds for you to create the passkey. Once you have a passkey, you'll be able to sign in to your Google account on any device. Now, I'll show you a quick demo while you try it out as well. Let's say I have a fictional bank, and I've signed into the website. OK. So my bank is on top of their game. They've just implemented passkey support. When I log in with my password, the bank detects that my device supports passkeys. And it will ask me, hey, do you want to use a passkey to log in next time? They suggest it will bring stronger security, so I will say yes. This prompts me to create a passkey for my banking site on this device. I need to confirm using my screen lock method. In this case, I use a fingerprint. Once I touch the fingerprint sensor, success, I've created a passkey. Next time I sign in, I will automatically get an option to sign in with a passkey. Signing in will simply require that I unlock my phone with the same method I used previously, a fingerprint. Signed in? That was quick, right? So the major benefit of passkeys is that they offer a much simpler sign-in experience for users. There's no typing required. The account selector will show you which passkey you can sign in with. And users simply need to select their credentials. Another benefit is that users can authenticate with biometrics, such as fingerprint sensor or a face scan. But really, they can use any method that unlocks their screen. So you can sign in also with a PIN or a pattern, if that's your screen lock method. Now, let's talk about security. This is a major advantage of passkeys over passwords. They reduce the risk of data breaches and the risk of phishing. Like I mentioned, this is because passkeys work with public key cryptography. There is a private key, which is stored securely on the device, and this is created locally on the device when you use your screen lock functionality. The matching public key will be stored on the server. Now, because no secret is stored on the server, passkeys are not as vulnerable to server breaches as passwords are. If an attacker hacks your server, they will not be able to derive your private key from the data they can find with the public key. Now, important to know is that the user's biometric information will never be revealed to the website or the app. The biometric material never leaves the device. And another security feature of passkeys is its metadata. So a passkey will inherently include the username and the server domain, so that apps and sites know which passkey to ask for. This passkey metadata is what ensures it can only be used for the service it's created on, because it makes it bound to the website's or app's identity. So when a user authenticates with their screen lock method on their device, the passkey authentication will generate a signature, which the server will then verify against the public key. So unlike with passwords, you're not actually sending the passkey to the server to match. You will only be sending a message that, yes, this user on this device has the right credentials to sign in. Then that gets matched against the public key, and the user is in. Now, like I said, by default, a passkey is tied to the single service a site or an app has been created on. However, tying a passkey to only one website does prevent it from being used to sign in into sketchy apps or like wherever. However, it creates some issues. So, for example, many sites have multiple domains, and even though they are managed by the same company and offer the same service. A simple example would be an example.com site, which also has country-specific domains, like example.co.uk or example.fr. So in this case, users can't use the same passkey to sign in across different domains, even though they should technically only need one user account to do this. Another example are branded domains, where a site could have like one domain, say acme.com, and then they can spin off another domain, acmerewards.com. We run into the same issue here. Both of these sites should be able to serve the user with the same account, and it would be really convenient if you could use the same passkey for both of them. And then we come to mobile apps, which often don't have their own domain, which makes credential management challenging. There are workarounds for this based on identity federation. You could do something with iframes, but that's not very convenient. So passkeys have evolved to serve this use case as well. We now have related origin requests, which allow websites to specify a list of related origins which can use the passkey that was originally created for the main site or service. I will get back to this when we come to the code part of my session. But if all of this sounds cool, you might be wondering, where are passkeys supported today? Well, I'm happy to say they're already supported across all major browsers and platforms. So Safari, Firefox, Chrome, Edge, and other Chromium-based browsers. But it's even better than that. They work across other operating systems, so Android, iOS, and Windows. Now, since passkeys work on both sites and apps, they can also be backed up and synchronized across devices with credential managers. It's a thing we traditionally used to call a password manager, but really now that we have passkeys, it's more fair to say that this is a digital vault for any sign-in credentials you have, both passwords and passkeys. When a user creates a passkey for a website on their phone, the phone's credential manager will back it up. If a user gets a new device, they can recover their passkeys as long as they're able to sign into the same credential manager. Now, there are some tricky things about this. On Android 13 and below, users could only use Google Password Manager. Other companies have similar capabilities for passkeys that only work with their credential manager, like on Apple devices, passkeys are synced with Apple Keychain. However, we made progress. So since Android 14, users can save their passkeys in any preferred credential manager, and this can be a third-party credential manager, like 1Password, for example. Now, passkeys that are created on Android are by default stored in Google Password Manager. They are encrypted on device, and then they can be synchronized. So for example, if a user creates a passkey on their Android device, it will be available on all Android devices where the user is signed in with the same account. However, this same passkey will not be available on Apple, Windows, or Chrome OS devices, even if you're using the same browser like Chrome. Now, the good news is we're working really hard on making this possible, and Google Password Manager will sync to all of these devices by the end of this year. For now, if you're signed into Chrome on both an Android device that has a passkey and, let's say, a Windows Apple Chrome OS device that doesn't, you will get a push notification on your Android device to use your passkey to sign in on the other device. Now, I'm all saying all this to reiterate, passkeys are not a proprietary technology, and while there are some limitations today, there's a lot of work underway to make use as seamless as possible across the ecosystems. In the meantime, if you want to sign in on a browser, on a device that doesn't have your passkey, you can also do it by scanning a QR code. So, for example, I can use a passkey on my Android phone to log into a site on my friend's Mac computer. I just need to have the phone close to the laptop so I can authenticate on that device. I'm going to try to show you a little video of how that would work. OK. Let's go back to my banking site. So I have a passkey on my Android phone, but I want to sign in on the computer. I get the prompt. And then a one-time passkey signature will be transferred back to this Safari on the Mac, so I can sign in. So this is a standardized mechanism, and it's available in Chrome, and Safari and other browsers will follow. There's nothing you need to do to enable this experience. So I've told you how great passkeys are. Now the question is, can we just get rid of passwords? No, not yet. So passwords won't disappear overnight. Like any new beginning, the change to passkeys will take time. So passwords and two-factor authentication are here to stay for the time being. But I like to think about it as a transition from cash to cards. We used to rely solely on cash, and when cards were introduced, it took a while to get into the groove. And not all places moved at the same pace. So I live in London. I can pay by card anywhere. Some places I can only pay by card now. I think it's same here in France. But for example, in Germany, especially in Berlin, even until recently, a lot of places insisted on using cash. But when I went to visit this year, it was less and less. I could pay by card in most places. So I feel like it will be similar for passwords and passkeys. Because passkeys are supported on fairly modern devices, a lot of services and sites will have a portion of users on all devices that might not support passkeys. So you should be able to let users sign in with both methods. But as time goes on, this will improve. And I will say, because passkey support is so good now across so many platforms, now is the time for you to invest in the future and start adding passkey support to your authentication systems. Now, let's take a look at the anatomy of a passkey system. What are all the elements you need to implement passkeys in your app, and how would you go about that? There are a few key terms when we talk about passkeys. One I would like you to remember, because I'll go back to it in the rest of the presentation, is relying party. So this is the site that handles issuing passkeys, authenticating them on the client, and then registering, storing, and verifying them on the server. Really, it's the website that the user will sign in with passkey to. Another thing you need is an authenticator. That's a device which creates and verifies passkeys using a screen lock. So my phone is my authenticator in this case. And then an important piece is the credential manager. So it could store and synchronize your passkeys to make it easier to sign in across different devices. So if you have a web app, it would look something like this. We have 4 components. we need a browser, which needs to run JavaScript for this to work. We need the authenticator, which will create and store the passkeys. Now, like you've seen with the QR example, an authenticator can be on the same device as the passkey, or it can be a different device and you use the QR code. Then you also need a backend server, which will store a database of public keys. And then you also need the front end to communicate between these elements. Now, let's look how you can integrate passkeys in your service with WebAuthn, which is a standard JavaScript API. Let's say your user already has an account where they sign in with the password. Once they're signed in, you show them a prompt to create a passkey, and they say yes. Now, the front end will need to call a function to create the passkey. The function is called navigator.credentials.create. This function returns a promise. Now, with this function, front end also needs to request some information from the backend to create the passkey. Now, here are some of the parameters you should provide. RP stands for relying party. Now, that's the domain that your passkey will be associated with. By default, passkey will only be usable for that domain. And I will go over this basic example, and then I will show you how you can add more origins with related origin requests. Now, this is the basic information that will be displayed when the account selector shows up. So, user ID is the unique identifier for the user on your app. So it shouldn't be a personally identifiable information like email address or username. Usually, it's good to make it a random 16-byte generated value. Then the username is the user-friendly identifier, like your email or a username, something that the user will recognize. Exclude credentials, which will prevent registering the same device by providing a list of already registered credential IDs. Now, when you set authenticator attachment to platform, means that this passkey will be limited to authenticating a user via built-in functionality, like a fingerprint scan on a specific device. But I want to mention that you could also have a hardware device, like a security key. These would be called roaming authenticators, which can be used with laptops and mobile devices. But I will not go into that today. And then setting require resident key to true will indicate that this needs to work without the user entering a username. Now, I skipped over the challenge, which is a random server-generated array buffer, which will prevent replay attacks on this. This is required during the registration, but it's usually not used unless you're doing attestation, which is an advanced topic I will not go into today. Now that we have all the parameters, the passkey will be created after the user consents with their screen lock. Then the promise is resolved, and the public key credential is returned to the front end. Now, what front end needs to do at this point is send the public key to the backend, where the backend will store the credential ID and the public key that's associated with it. Now, let's look what's needed to actually sign in the user with the passkey. It will look familiar. On the front end, you will call navigator.credentials.get. This function will initiate authenticating with the passkey, and it will also return a promise. You will request a challenge from the backend, which is generated on the server to prevent replay attacks. Now, RP ID will be the same one that was used during the creation of the passkey. When you set mediation conditional, this will allow the authentication dialog to only be displayed if a passkey is found on the device. So, here's how this would play out. When the user puts the cursor in the sign-in field, the browser will just display an autofill dialog, which will include both passwords and passkeys. Now, if the user selects a passkey, then a passkey authentication dialog appears. After the user verifies with their screen lock method, the promise will be resolved, and the public key credential will be returned to the front end. Now, the front end will send that public key to the back end, which will then be able to verify the signature against the match account's public key. If that succeeds, the user is signed in. Now, to allow passkey reuse across sites, you use related origin requests. I will show you how that looks now. What you need to do is serve a JSON file at the specific URL. So the URL will be the URL of your relying party. So whatever you put into your RPID, it would go as follows: your example.com/.wellknown/webauthn. And this is where this JSON file lives. And in the JSON file are the sites you want to register. So if our site is example.com, and the JSON file lives at the well-known URL, you would specify a few more sites that you want to allow using this passkey on. So example.co.uk.de, or any other site. The sites that are listed here will now also be able to use the same passkey that was created for example.com. Now, next time any of these sites makes a call to sign in with a passkey, the browser will notice that the relying party ID doesn't match what's in the passkey call. What it does then is it will know to go looking at this specific URL for this file, and then it will look for the origin that's requesting to sign in with a passkey. If that matches, it will initiate the authentication. And if the browser doesn't support passkeys or the sites don't match, it will just throw a security error. Now, related origin requests allow you to relate multiple sites in this way. However, if you want to use the same passkey across a site and a mobile app, you use a different thing. So in Chrome, you would use digital asset links, and in Safari, you would use associated domains. I will say digital asset links are also what enables you to reuse passwords across sites and apps. So if you do run the same service as an app and a site, you should look into this. Now, in the previous code examples, I mentioned autofill dialog, which will offer you both passkeys and passwords. Here's how you enable this autofill to work. I love it because it's so simple. It's just HTML. On your input form, you will simply add WebAuthn token to the autocomplete attribute. Then when the user taps on the input field, the browser will display passkeys as the part of the same autofill that offers passwords. Now, I think this is what will help users transition more seamlessly between passwords and passkeys. For step-by-step instructions on how to implement this, we have a lot of useful resources at the websites I mentioned. So you can scan this QR code and go to the workshop that's linked. But if you don't want to start from scratch and go step by step, there's a number of libraries that can help you get a quick start. They're available for all the languages. You can have it in TypeScript, Ruby, Rust, and so many others. And you can find the list on this GitHub repository, Awesome WebAuthn. Now, I didn't really have time to go into the server-side implementation today, but there are also libraries for languages like Java and PHP, and we also have code labs and resources for you to learn to do that. You've seen the code, but let's see what's a good user experience. When in the user journey, you should create a passkey. We've done some research, and here's what's shown as good options. Right after sign-in, this is a great time. So at this point, the user is actually focused on authenticating and getting in. There might be even thinking about security. And this sets them up for a faster process and success in the future. Let's say they sign in. And once they're signed in, you can offer them to create a passkey and offer them an encouraging message, like pitch performance or security at this point. And once the passkey is created, it's good to let the user know it has succeeded. So give them a success message and let them move on in their own time. Another great opportunity is account recovery. Now, this is never an easy process, and users will be likely frustrated, and they will also be thinking about security if they have to recover their account. So once you get the user back in, this is a good moment to pitch creating passkeys to them. They will think about the enhanced security this will offer, and it will streamline their future interactions. Now, sometimes it's necessary to ask the user to re-authenticate if they're doing a sensitive action, like authorizing a payment, even though they're already signed into your app. After this is completed, it's also a good time to offer them passkeys so they can do this process faster next time. And if you have passkeys, you should also offer the options for managing them from account settings. So this would allow a user to manage all the passkeys they have, create new ones, or remove the ones. And this is also where you should offer a backup re-authentication method, like an email or a mobile phone. OK, let's recap what have we learned today. Passkeys are a replacement for passwords. You don't need to type in anything. The device will offer you a passkey to sign in with. They work with your screen lock method. So it can be a fingerprint, a face scan. It can also be a PIN or a pattern. And what makes them so convenient for users is synchronization across devices with the credential manager. They are much more secure than passwords because they're based on public key cryptography. And also, they are much more resistant to phishing. They are supported across all major browsers and platforms. To learn more about passkeys, you should check out the documentation on developer.google.com. This is a convenient short link where you can get to it. And I would say we are well on the way to a passwordless future. If you decide to implement passkeys today, you will get better security, a better user experience, and in the end, happier users. Thank you so much for your attention. I'm happy to take any questions you have now. And if you're more comfortable asking them in French, Matthew will help translate.